Excuse me, could I please have the starting slide? Good morning, ladies and gentlemen. My name is Hans-Dieter Schwaben, and I'm the product manager for Polystyrene Europe of the newly formed company Styrevolution, which is a joint venture of the former styrenic businesses of BASF and Ineos. When I saw some months ago the headline of this conference, Green World of Plastics, it has been immediately clear to me that I should try to go there and talk to you about my conviction why polystyrene, a fairly mature product which is in the marketplace since nearly 8 decades, is and will continue to be an excellent choice even in the area that we are now typically talking about or describing with slogans like sustainability or green. So that is why I am here today. And first of all, I'd like to explain to you what polystyrene makes unique. Second, I'd like to give you a market update and future perspective for how we see for that product. I will talk a little bit about polystyrene in the interpolymer competition in packaging. And in the last part of my speech, I will talk about polystyrene and the sustainability challenge. So let's start with the first topic. Polystyrene has more than 50 years of experience and safe use in food packaging. Portion packs by form-filled seal technology, which is a real strength of polystyrene, are cost-effective, convenient, and are saving precious food. Polystyrene is the easiest material to foam. You can make use out of this property in producing lightweight packagings and, of course, insulation at buildings. Polystyrene is a very transparent and brilliant material, and therefore an excellent choice to make drinking cups. And finally, and last but not least, polystyrene is the easiest polymer for processing, and due to the existence of general purpose and high impact polystyrene, which can be mixed in each ratio, tailor-made physical properties can be achieved. So finally, all in all, the combination of its characteristics makes polystyrene, and that is behind the shadow of the camera, unfortunately, unique. Let's talk about the market update and the future perspective. So, the key markets for polystyrene, which are food packaging and disposables, large appliances, and building and construction. So these three segments, which make up for more than 80% of polystyrene applications, will continue to grow at reasonable rates in Europe. This is one aspect about the key markets for polystyrene. The second important aspect is shown here in this diagram, where we have summarized the migration tendency of different industries to China. You see here on the axis the cost advantage of China rated from low to high, and here you see the mobility of certain industries for translocation of production from low to high. I don't want to go into each of these industries. I only want to explain one example: footwear. Today, I believe everybody knows that, let me say, more than 90% of shoes they are produced in China or Southeast Asia. And the reason is very simple. The cost advantage of producing shoes, footwear there is significantly, and the mobility of this industry is very high. Looking into our industries, which are important for polystyrene, our conclusion is that the key market for polystyrene, that once again, packaging, construction, and large appliances. I don't say that they will not move, that nothing moves to China, but our conclusion is that our industries are significantly less threatened by this migration to China. So that is another positive aspect for our industry. During the economic crisis in 2009, the demand for polystyrene in Europe and also our export opportunities have been reduced. But since then, we see a steady recovery of the European demand. The industry in Europe has reacted to that by closing fairly old and less effective plants, so that finally demand and supply are coming into balance with utilization rates of the industry of above 90%. Polystyrene in the interpolymer competition in packaging. And more specifically, I'd like to talk about the interpolymer competition in rigid food packaging. Besides the price, today there are, four polymers are competing in this industry, in this application mainly. It's polystyrene, polypropylene, PET, and most recently PLA as a so-called biopolymer. And besides the price, we have now selected 10 major criteria that typically influence the material selection. And for each of these criterion, we have awarded up to 10 points for the material that performs best and 0 points for the material that performs worst. So now let's start going through these criteria. Criterion number 1 is material consumption or density. Here, the clear winner is polypropylene. Polypropylene has the lowest density, so everybody knows a cup from polystyrene, or for producing a cup of polystyrene, you are needing the lowest amount of material, followed by polystyrene. The polyesters have a fairly high density, so cups have a fairly high weight, so you need significantly more material. Next criterion is processability. According to all what I have heard in many years, polystyrene is really the world champion with respect to processability, easiest material to process, no pre-drying required, which is typically a hurdle for processing PET or even PLA. Energy consumption. Here once again, polystyrene is the world champion. The energy you need to process this product is significantly lower than polypropylene or even PET or PLA. So finally, your energy bill you have to pay month by month will be lowest when you are processing polystyrene. The carbon footprint, a new criteria that is getting more and more importance. Here, our analysis is that polystyrene and polypropylene are on the same level. PET and PLA are behind. Versatility, we rate polypropylene slightly better than polystyrene, and PET and PLA a little worse. In transparency, it is very clear and obvious to everybody that here PET is the world champion, followed by polystyrene and polypropylene,
comes a little after that. The same for mechanical properties. Here mainly the combination of stiffness and toughness. PET is leading, followed by the other polymers. With respect to recyclability, we rate polystyrene and polypropylene fairly high, PET and PLA significantly lower. Since we have one bioplastic here on that slide, that is PLA, so for several people, or for some people, the criterion renewables-based is important. Of course, PLA is renewables-based, therefore it gets 10 points. The classical polymers are fossil-based, they get 0 points. But if we take this criterion, renewables-based, we also have to look at competition to food. And here it is the opposite. The classical materials get 10 points, while the PLA gets 0. So all in all, you see here the rating, polystyrene 80 points and is leading the race. So the answer to the question, which product does best as a combination out of these 10 criteria, it is our strong belief that polystyrene is the best material for this application. Now I'd like to come to what I've called polystyrene and the sustainability challenge. In the discussions about sustainability, when you go into the press, you find, let me say at least, many different slogans that describe sustainability. So sometimes some people are talking about a so-called eco-confusion. Sustainability, what is that? What is it? Everything? Our analysis with respect to that is that 4 slogans or major sustainability targets are crystallizing in the discussions. These are the energy efficiency, it is recycling, it is waste reduction, and it is bio-based. And now let's have a look how polystyrene supports you in achieving these 4 targets. And I'd like to start with energy efficiency. And I'd like now to have a look into 2 major applications for polystyrene. The first one is the polystyrene cup. It is polystyrene cup has a combination of low weight at high mechanical strength. It is no pre-drying is required. And as this slide below shows, polystyrene has by far the lowest energy consumption in processing. So that is the polystyrene cup. And another application I'd like to talk about is the XPS insulation board. These XPS insulation boards for buildings are well known to save energy during the lifetime. It has just before, the speaker before mentioned that already. I've here now brought with me graphic descriptions about that. And what you see here on this slide are the carbon dioxide emissions or savings of 1 square meter of XPS. And for producing this 1 square meter of XPS, you need a certain amount of energy. And we have calculated this amount of energy into CO2 emissions. And the result of this calculation is that 14 kilograms of CO2 are used during production of this 1 square meter of XPS. And now if we look into the savings over 50-year lasting application in a building, it is not 100, not 500, not 1,000, it is 7 7,000 kilogram, that means a factor of 500 in energy is saved. So all in all, this slide shows that polystyrene in two of its main applications, the classical cup plus the insulation boards, just two examples, is an extremely energy efficient material. Now, let's have a look into recycling. A question to the audience. Who of you already had a part from recycled polystyrene in his or her hands? Please raise your hand. Who had ever a piece of recycled polystyrene in its hand? One out of, I don't know, 200. That would mean 0.5%. I expected that. And all the rest, for all the rest, I brought something with me. And that's why I have this bag here with me. I have here some pencils made from recycled polystyrene. And since we are a new company, and I want you to remind myself, we have printed our new logo on it. So I just now walk around only in the first row and distribute a few. Okay, so please everybody can take one. And all the rest, I put it over here. So after that conference, everybody can go out and say, hey, now I have had a piece from recycled polystyrene in my hand. So this example, this is just one example out of here where I said manifold proven examples. So besides the pencils, there are many other. And today, as of today, they are not so really obvious in the society. And that was also the result of the answer of this audience to my question. But there is something, and the whole industry is working on to improve that. But we all know, and this also some of my pre-speakers have mentioned already, that it will never be economical or ecological, sustainable to recycle really everything. To recycle every single yogurt pot out of polystyrene will never work. And therefore, the energy recovery is the preferred complementary option to a mechanical recycling. And here it is worth to emphasize again and again that polystyrene has a heat of combustion, that means an energy value, which is really comparable to natural gas or crude oil. So I always say, due to that, used articles from polystyrene can be considered as a very valuable energy resource, and I sometimes call it's solid oil. And this diagram also shows that this heat of combustion, the energy value is significantly higher than coal. It is double than PET or bioplastics, or nearly 3 times as high as cardboard or paper. And this is not, what I'm telling here is not just theory. Let's have a look into one single country, and I selected Denmark. And in Danish energy from waste plants, today electricity and heat for about 16% of the population is generated. If you ask me, I can say the Danish are very clever people. They are reducing the price they have, their bill for crude oil or for natural gas to generate heat and electricity. Waste reduction. And here I'd like to look into the area of food and food packaging. And I believe that it is here extremely important that we have a real comprehensive look upon reality. And reality means that at the end, there is not only the empty packaging that is remaining, but the vast majority of the waste from the segment food and its packaging is the food thrown away by consumers. So this is a typical issue in Europe, for instance. And here, two citations. 7% of Sweden's climate impact depends on the food we throw away. And just recently, a study by the FAO has been published showing that in Europe, consumers throw away each year about 70 million metric tons of precious food. So once again, this is not the food that is spoiled due to bad packaging. That is the food that I buy in the supermarket, but I don't consume it. I buy more than I eat and I throw it away. And therefore, it is important to see that if you look and if you take all this into consideration, you see that the carbon footprint from what we throw away on wasted food is 4 times higher than the plastics. Of course, we have to be aware that plastic waste is an issue and we have to take care about it. But the full picture really is that the highest leverage is the food we throw away. And now let's have a look. What does that particular mean for polystyrene? How can we support that? And for today, I have prepared a simple question, an example. What is better? If you want to buy 500-gram yogurt and you are in the supermarket, what is better from a carbon footprint point of view, not from a price point of view, to buy it in such portion packs, 4 times 125 gram, or buy a big one? And an easy analysis and calculation shows that if you buy big portions, you typically throw more yogurt away in comparison when you buy such small things. So at the end of the day, you see here that 2 major conclusions. Just for this example, that 97% of the total carbon footprint of that originate from the yogurt and just 3% from the packaging. But despite this correlation, a proper selection of the packaging, here FFS portion packs, can reduce the overall carbon footprint by 4% due to less yogurt thrown away or wasted. Bio-based, just a few remarks about that. The typical route today to produce polystyrene is from fossil resources, crude oil via naphtha, and then ethylene and benzene as the 2 major building blocks are needed to produce styrene, and from styrene, polystyrene is produced. Now the big question is a polystyrene based on renewables a fiction, or is it just a vision? So renewable resources, for instance, sugarcane, corn, or wheat, are today, especially in Brazil or in the US, transformed into bioethanol. And in Brazil already, one industrial plant, one industrial process is running in producing ethylene from renewable resources. So one building block, in principle, is accessible. The other building block, which is benzene, here a lot of, or several research projects worldwide are ongoing, and currently the expectation is that it will take about 5 to 10 years until commercialization. So purely from the technical point of view, a styrene and therefore a polystyrene based on renewable resources is a very realistic option. It is not a fiction. The question is, when will it be economically? I cannot answer that today. But technical and economical are only two aspects of this story. The third one is shown here. Today, wheat is typically used to produce food, to feed to feed the people. And now there is a certain competition ongoing to use renewable resources in the industry to produce plastics, for instance. Technically, this is possible, but from Styrolution's perspective, this is ethically not acceptable. So we on our side, we will never contribute in any mechanism or process like that where we are in competition to food. So that was what I wanted to tell you today. Thank you very much for listening to me, and I believe questions and answers are to come later. Thank you very much.